All right, so get this. Today we're doing a deep dive into integer sequences.
Oh, wow.
You know, like those ordered lists of whole numbers, like
Right.
1, 2, 3, 4, or like 2, 4, 8, 16.
Right.
We've got this research paper,
Hmm.
and it claims that there's this computer system that can actually discover the programs to generate these sequences all on its own.
It's a fascinating idea, almost like teaching a computer to think like a mathematician.
Yeah.
And the implications, pretty mind-blowing.
Okay, so back up for a second. What's the deal with these integer sequences? Why should we care?
Well, integer sequences, they're more than just these like lists of numbers.
Yeah.
They often point to like deeper patterns and relationships
Right.
in math.
Yeah.
And the really cool thing
Yeah.
is there's this massive online database
Okay.
called the OEIS. It's the Online Encyclopedia of Integer Sequences.
Wow.
It's got over 350,000 of them
Right.
as of March 2022,
Okay.
when this paper was written.
350,000. That's a lot of sequences.
It is, yeah.
So this research focused on teaching an AI to like crack the code of these OEIS sequences.
Exactly.
Okay.
The researchers wanted to see if a computer could learn
Uh-huh.
to generate programs that would output these sequences,
Okay.
essentially rediscovering the mathematical rules behind them.
Hold on. Programs. So we're talking like actual computer code here.
Yeah.
What kind of programming language are we even talking about?
They actually designed a simplified language
I mean-
specifically for this project.
Got it.
Think like basic math operations,
Okay.
addition, subtraction, multiplication, division, modulo,
Mm-hmm.
plus some fundamental programming structures like variables, conditional statements, and loops.
Okay, so no need for me to dust off my old coding textbooks then.
Not at all.
Okay, good.
The idea was to keep the programs readable
Yeah.
so mathematicians could understand them.
Gotcha. Okay, so walk me through this.
Sure.
How does this AI system actually learn to write these programs?
Well, it's based on a principle called Occam's razor.
Right.
The idea that the simplest explanation is usually the best.
Right.
So the system searches for like the shortest, most elegant programs that can generate the target sequence.
Makes sense. So it's not just randomly spitting out numbers.
Right.
It's trying to find the most efficient way to
Right.
generate them.
Precisely. It works in a three-phase cycle.
Okay.
First, it randomly generates programs
Yeah.
using those building blocks we talked about.
Yeah.
Then it tests those programs. Does the output match any sequences in the OEIS?
Mm-hmm.
And finally, the system learns from its successes.
Okay, so this is where the AI part really kicks in.
Yeah.
How does it actually learn?
It uses what's called a tree neural network.
Mm-hmm.
Imagine like a branching tree
Okay.
where each branch represents a different program.
Right.
The network learns to prioritize certain branches, the ones that have led to successful programs in the past.
So it's constantly refining its search.
Yes.
Based on what's worked before.
Exactly.
Kind of like a detective following the strongest leads.
That's a great analogy.
Awesome.
And as the system goes through more cycles,
Hmm.
it gets better and better
Wow.
at generating programs
Right.
that match the OEIS sequences.
All right, so you've piqued my curiosity. How
Ah.
well did this thing actually work? Did it manage to, like, crack any of those 350,000 sequences?
So get this. After a full run,
Uh-huh.
the system had created programs for a whopping 27,987 OEIS sequences,
Wow, okay.
almost 8% of the entire database.
Wait, hold on.
Yeah,
So this AI is basically reinventing some classic mathematical theorems.
it is, yeah.
That's pretty profound.
It is.
But how do we know it's not just memorizing sequences?
That's a good question.
Like, did the programs actually generalize?
That's the really exciting part.
Okay.
They tested the programs
Mm-hmm.
by seeing if they could accurately predict terms beyond what they were trained on. And about 92% of them could generate at least 100 extra terms correctly.
Okay, you've convinced me.
Good.
This AI is a mathematical whiz.
It is.
Now show me the magic.
Right.
What are some of the cool sequences that it actually figured out?
Let's start with a familiar one, the Fibonacci sequence.
Okay.
0, 1, 1, 2, 3, 5, 8,
Right.
where each number is the sum of the two before it.
Ah, good old Fibonacci. I've always found it fascinating how this sequence pops up everywhere in nature.
Yeah.
From the spiral patterns of seashells
Right.
to the arrangement of sunflower seeds, like it's
Mm.
everywhere.
It truly is a fundamental pattern in
Right.
mathematics and nature.
Yeah.
And the AI system was able to generate a program for it
Okay.
using a loop structure
Uh-huh.
that perfectly mirrors how the sequence itself is built.
So it wasn't just mimicking the numbers, it was capturing the underlying logic.
Exactly.
That's impressive.
It is, but the Fibonacci sequence is relatively straightforward.
Okay.
Let's move on to something a bit more challenging.
Right.
The Catalan numbers.
Okay.
These are crucial in a field of math called combinatorics,
Okay.
which deals with counting possibilities.
Counting possibilities. I'm intrigued. Give me an example.
Imagine you have a set of parentheses.
Okay.
The Catalan numbers can tell you how many ways you can arrange them in a valid, balanced way.
Okay.
For instance, if you have 3 pairs of parentheses,
Uh-huh.
there are 5 possible balanced arrangements.
Okay, so this sequence is definitely more complex than Fibonacci.
Yeah.
How did the AI handle it?
What's fascinating is that it independently rediscovered a known formula for calculating Catalan numbers.
Okay.
Its program, while structured differently, arrived at the same mathematical truth
Right.
that mathematicians had already discovered.
So it's not just solving problems.
Right.
It's rediscovering the tools and formulas mathematicians use.
Exactly.
That's incredible.
Yeah.
But surely there were some sequences that stumped it right.
Of course, it didn't solve everything, but its successes are truly remarkable. For instance, it even tackled the prime number sequence.
Prime numbers. I remember those from school. They always seemed a bit mysterious.
Well, the AI went beyond simply generating the prime number sequence.
Okay.
It actually rediscovered methods for testing whether a number is prime.
Really?
Some of these methods,
Yeah.
like Wilson's theorem, are quite sophisticated.
That's wild. It's like it's uncovering the building blocks of number theory
Yeah.
as it goes.
Yeah.
But I'm guessing it wasn't all smooth sailing.
Right.
Were there any sequences it struggled with?
There were certainly challenges.
Okay.
For example, it grappled with a particularly tricky one, the Ackermann function.
Okay.
This function grows at an unbelievably fast rate,
Hi.
making it notoriously difficult to work with.
Okay, you've lost me a bit. What makes this Ackermann function so special?
It's a function that grows so rapidly that it can't be defined using just simple loops and basic operations. Mathematicians call this not primitive recursive.
Okay.
It's like a function that explodes in complexity.
So did the AI manage to find a solution for this explosive function?
It didn't find a perfect solution, no.
Okay.
But what's intriguing is that it came up with an approximate solution that got remarkably close to the actual Ackermann sequence, even though it couldn't fully represent it within the limitations of the programming language.
So even in its failures, it's pushing the boundaries
Right.
of what's possible
Exactly.
and giving us insights into these complex mathematical concepts.
Yeah,
I love that.
absolutely. And to round out our little tour of sequences,
Okay.
let's look at one that involves a truly massive number,
Okay.
a googol.
A googol. Now we're talking big leagues.
The system discovered a program for a sequence that incorporates the googol in its definition.
Okay.
It involves taking the googol modulo, a series of numbers.
Modulo. The quick refresher on what that means.
Modulo, or the remainder after division, is like figuring out what's left over after you divide one number by another.
Right.
It's a key concept in number theory and cryptography.
Okay, got it. So this AI was able to handle calculations involving a googol
Yes.
and this modulo operation. That's pretty mind-blowing.
It really highlights the system's ability to handle vast numbers and complex mathematical concepts.
All right, I'm sold. This AI is a mathematical rock star. But I have to ask, what does this all mean?
Right.
What's the bigger picture here?
You see, this isn't just about a computer crunching numbers.
Right.
It's hinting at the possibility that AI might help us uncover hidden mathematical structures we haven't even dreamed of yet.
That's a tantalizing thought. Could AI become like a partner for mathematicians,
Yeah.
helping them push the boundaries of the field?
The possibilities are truly exciting. We might be on the cusp of a new era
Yeah.
in mathematical exploration where AI helps us see patterns and connections that were previously hidden.
It almost feels like science fiction. An AI uncovering hidden mathematical truths.
Right.
And to think this system started with zero
Yeah.
pre-programmed knowledge.
Right.
It learned everything from scratch just by experimenting with these programs and comparing the output to those OEIS sequences.
What's remarkable is that the system relies on a surprisingly simple programming language.
Right.
Those basic building blocks.
Yeah.
The arithmetic operations, the loops, the conditional statements.
Yeah.
They were enough to rediscover some pretty profound mathematical concepts.
It's a testament to the power of elegant code and fundamental mathematical principles.
It is.
But let's get back to those possibilities you mentioned.
Yep.
Could AI systems like this actually change how math research is done?
I mean, imagine a future where mathematicians have these AI partners
Right.
that can help them test hypotheses,
Yeah.
explore new mathematical landscapes, even suggest new avenues of research.
That's a pretty exciting thought.
It is.
It wouldn't replace human intuition and creativity,
Right.
but it could amplify our ability
Yeah.
to explore like this vast world of mathematics.
Precisely. AI could become a powerful tool for uncovering hidden patterns and connections
Yeah.
that might have taken human mathematicians years, even decades, to
Right.
discover on their own.
It's like having a tireless research assistant
Right.
who can sift through mountains of data
Yeah.
and point you in the right direction.
Exactly.
I'm also thinking about the educational potential here.
Yeah.
Could this kind of AI help students grasp these complex math concepts
Yeah.
by like showing them the underlying logic
Right.
in a visual, interactive way?
Absolutely. Imagine a student struggling to understand the concept of prime numbers.
Right.
An AI system could demonstrate how different algorithms for testing primality work,
Yeah.
allowing students to explore those concepts in a more engaging and intuitive way.
This deep dive has left me feeling incredibly optimistic
Yeah.
about the future of mathematics. It feels like we're on the verge of a new era of discovery.
And it all stems from these seemingly simple integer sequences.
Right?
Who knew that lists of whole numbers
Yeah.
could hold the keys to such profound mathematical insights?
We've covered a lot of ground today.
We have.
But before we wrap up,
Yeah.
I want to leave our listeners with a challenge.
Okay.
Head over to the OEIS website.
Yes.
We'll put a link in the show notes
Mm-hmm.
and spend some time browsing through the sequences.
Yeah.
Find one that catches your eye,
Right.
one that sparks your curiosity.
Uh-huh.
Then try to imagine the kind of program
Okay.
that could generate it.
Yeah.
Think about the basic operations,
Hmm.
the loops, the conditional statements.
Right.
It's a great way to flex your mathematical muscles
It is.
and to appreciate the beauty of patterns and algorithms.
Yeah.
And who knows, you might even stumble upon a new mathematical insight yourself.
We might,
Until next time, keep exploring the fascinating world of numbers.